Hello everyone, and I'm back to give you a lecture on integral calculus, and this time we are going to talk about those integrals leading to an inverse trigonometric function. So let's get into business. We first recall the derivative of the three inverse trigonometric functions, namely the derivative of arc sine of u, that is equal to du over the square root of 1 minus u squared, and the derivative of arc tangent of u is equal to du over 1 plus u squared, and the derivative of arc secant of u is equal to du over the absolute value of u times the square root of u squared minus 1. And from this relationship, we can now see that the integral of du over the square root of a squared minus u squared is equal to arc sine of u over a plus c. And we have the integral of du over a squared plus u squared, or you can write this also as u squared plus a squared, and that is equal to 1 over a arc tangent u over a plus c. And finally, we have the integral of du over u times the square root of u squared minus a squared, that is equal to 1 over a arc secant u over a plus c. And as an illustration, let us first integrate. I have integral of dx all over the square root of 3 minus x squared. So to easily facilitate the integral, we shall look for the value of u squared and a squared. So we can now see here that u squared is equal to x squared and a squared is equal to 3. Getting the square root of the both sides, we have u is equal to x and a equals square root of 3. And differentiating u, we have du equals dx. And this integral can now be written as dx is represented by du, and 3 is our a squared, and x squared is our u squared. So we can now say that this is equal to arc sine of u over a plus c, and writing it back to the original variable, we have arc sine u is x and a is square root of 3 plus c, and that is arc sine of x over square root of 3 plus c. Another one. Okay, so this time we have integral of dx all over 4x squared plus 9. Similarly, we can now let u squared is equal to 4x squared, and that a squared is equal to 9. So taking the square root, so we have now u equals 2x, that's the square root of 4x squared, and a squared equals 9, so therefore a equals 3. Differentiating u, so you have du equals 2 dx, or 1/2 du equals dx. So which means this dx can now be replaced by 1/2 du, and this 4x squared is represented by u squared, and 9 is represented by a squared. So we now have 1/2 times the integral of du all over u squared plus a squared, and that will give us 1 over a arc tangent u over a, and then you multiply it by 1/2. Do not forget that 1/2 in front, then plus c. And then replacing u and a by 2x and 3 respectively. So you have 1/2 times 1/3 arc tangent 2x over 3 plus c, and then simplifying 1/2 times 1/3 will lead you to 1/6 arc tangent 2x over 3 plus c. Another one. So this time we have, dy all over y times the square root of 3y squared minus 25. And looking on these three formulas, you might say that that will lead us to arc secant, okay? Because of this y, okay? And that is our u. So you have u squared is represented by 3y squared, and a squared equals 25. Taking the square root again, so you have u equals the square root of 3y, and a equals 5. And then differentiating, du is now equal to square root of 3 dy, or 1 over square root of 3 du is our dy. So we now have this dy will be replaced by 1 over square root of 3 du, and this y, from here, you can now observe that u over square root of 3 is our y. So y will be replaced by u over square root of 3, and then times the square root of this 3y squared is our u squared, and this 25 will be our a squared. So you can now drop this off. This 1 over square root of 3 over square root of 3, you can drop this off. And finally, you have du over u times the square root of u squared minus a squared. And that leads us to 1 over a arc secant u over a plus c. And then finally, you have 1 over 5 arc secant. That is our u, that's square root of 3y over 5 plus c. One more. Say you have the integral of secant squared theta d theta all over 16 minus tangent squared theta. You can now see here that u squared is tangent theta, and u is equal to tangent theta, sorry, this is u squared equals tangent squared theta, sorry, and u equals tangent theta. Differentiating u, so you have secant squared theta d theta, which you can find it here, okay? And then you know that a squared equals 16 and a is equal to 4. So this can be written as integral of du all over the square root of a squared minus u squared. And this will lead us to arc sine of u over a, and finally that will give us arc sine of tangent theta over 4 plus c. Another one. So you have x dx all over 7 plus x to the 4. So you can now let u squared be equal to x to the 4. Then u is equal to x squared. Then du is equal to 2x dx. And once again, we have x dx here. So you have 1/2 du is equal to x dx. And then you know that a squared is equal to 7 and a is equal to square root of 7. So we can now replace this as integral of x dx, that is our 1/2 du all over 7, that is our a squared, then plus x to the 4, that is our u squared. And this is equal to 1/2 times 1 over a arctangent u over a plus c. And then you now have 1/2 times 1/2 times 1 over a, that's 1 over square root of 7. And then arctangent u is x squared over a, that's square root of 7 plus c. And then finally, we can have 1 over 2 square root of 7 arctangent x squared over square root of 7 plus c. Next, we have integral of dx all over x plus x ln squared x. Simplifying, I can now factor out x when I look on the denominator, so I can factor this out, x, so you have 1 plus ln square of x. And then here, you can now let u square be equal to ln square x, u is equal to ln x, and we now see that du is dx over x. So this dx and this over x will go together, and that will represent du. And you know that a squared is equal to 1, and therefore a equals 1. So this can now be written as integral of dx over x is our du all over 1, that's our a squared, plus ln squared x is our u squared. And this will again give us an arctangent. So that's 1 over a, that's 1 over a, where a is 1, arctangent u, which is ln of x, over a, which is 1, and then you add c. So finally, you have arctangent of ln of x plus c. Then, integral of x plus 1 all over x squared plus 4 dx. Compared with the previous examples, when you look at the numerator, we have x plus 1 here. So what we can do here is to use distributive property of division over addition. So this can be written as the integral of x dx all over x squared plus 4 plus 1 times dx all over x squared plus 4. And you know that this leads us to an arctangent, and this is equal to 1/2 arctangent, that's x over 2, right? And then this one will give us an ln function because the derivative, when you let u be equal to x squared plus 4, and you have du is equal to 2x dx. And you now see that x dx is present on the numerator, and then you just only multiply this by 1/2. So we have 1/2, for this one is 1/2 ln of x squared plus 4. And finally, this integral will lead us to 1/2 ln x squared plus 4 plus 1/2 arctangent of x over 2 plus c. Next, what do we have here? All right. So we have integral of dx all over e to the x plus e to the negative x. One thing that you need to remember when an exponential function appears on the integrand is that dx should go along together with that exponential function, or an e to the x, or that exponential function should go along together with dx, because we know that the derivative, say e to the x, is e to the x dx. When you look at here, Okay, we have here e to the x plus e to the negative x. One straightforward thing that we need to do here is to multiply this by e to the x over e to the x. And multiplying, we now have e to the x dx all over e to the 2x plus 1. So that's e to the x times e to the x, that's e to the 2x. And you know that e to the x times e to the negative x is e to the 0, and that is 1. Okay, and then we can now let u squared equals e to the 2x and a squared equals 1. Doing it so, we have u equals e to the x and then a equals 1. And then differentiating u, you have du equals e to the x dx. And we see it right here. So this can now be written as du over u squared plus a squared, and that leads us to 1 over a arctangent u over a plus c, and that will give us 1 over 1 arctangent u, which is e to the x, all over a, which is 1, plus c. And therefore, that gives us arctangent of e to the x plus c. Number 9, let's see. Okay, so we have integral of dx all over e to the 2x minus 5. Okay, and here we can now let u squared equals e to the 2x and a squared equals 5. And then we can now see that u equals e to the x and a equals square root of 5. Differentiating, so you have du equals e to the x dx. When you look at the given, this dx do not have an e to the x on its side. Okay, so what are we going to do is, again, we multiply it by e to the x over e to the x, leading us with e to the x dx all over e to the x times the square root of e to the 2x minus 5. And this e to the x dx will represent du. This e to the x will be our u. Then this e to the 2x will be our u squared, and this 5 will be our a squared. So we got integral of du all over u times the square root of u squared minus a squared, and that leads us to an arcsecant. That's 1 over a arcsecant u over a plus c. And then we have 1 over square root of 5. Yeah, that's it. Arcsecant of e to the x over square root of 5 plus c. Let's have some more this time. All right. So we have integral of dx all over 3x minus x squared. When you look at this, okay, none of this, okay, form can be appropriated with 3x minus x squared, okay, because there's an x here. So to achieve this form, any of this three, okay, so we must complete the square. Okay, by completing the square, we first factor out -1 from 3x minus x squared. That led us to x squared minus 3x. So what are we going to add and subtract here is -3 times 1/2 and then raise it to the second power. So this is equal to -3/2, that's 9/4. So we will be adding 9/4 and -9/4 to x squared and -3x. So we have integral of dx all over the square root of -1 times the quantity x squared minus 3x. This is to be added, that's 9/4, and we have to subtract the same quantity so that the value of the function 3x minus x squared is not being altered, okay? And then, you know that since we apply completing the square, you know that this first three term exhibit a perfect square trinomial whose factor is x minus 3/2 square. And then you just copy that -9/4 or -9/4. And then the next thing you need to do is to introduce this -1, each term inside, leading us with, okay, dx all over the square root of 9/4 minus the quantity x minus 3/2 squared. And from here, you can now see that your a squared is 9/4 and that a is equal to 3/2, and your u squared is the quantity x minus 3/2 square, and that your u is x minus 3/2, and that du is dx. Okay, so we are now of the form du, the integral of du over the square root of u squared minus, that's square root of a squared minus u squared, and that led us to an arc sine. And therefore, that will give us arc sine of u, that's x minus 3/2 over a, that's 3/2. And then you just get the reciprocal of this, then multiply it to x minus 3/2, and that will lead us to arc sine of 2x minus 3 over 3. Okay, so that's 2 times x and 2 times negative 3 halves. Another example, say we have the integral of dx all over x squared plus 4x plus 5. Since you notice that on the denominator, there is no presence of the square root. So we might think that this integral will lead us to an arctangent. So we might use this second formula, that's the integral of du over a squared plus u squared. But the denominator happens to be a trinomial in form, not sum of two squares. Again, by completing the square, so we have 4 here, so you just get half of it, so that's 1/2 of 4, and then raise it to the second power. So this is equal to 2 square, so we will be adding and subtracting 2 on the function on the denominator. So that led us to x squared plus 4x plus 4 plus 5 minus 4. Okay, and then again, this 3 terms is a perfect square trinomial whose factor is the quantity x plus 2 squared, and then you subtract this 2. 5 minus 4, that is 1. So we can now say that our a squared is equal to 1. So therefore, a is 1. U squared is equal to x plus 2 squared, right? And then u is x plus 2, and therefore du is dx. So this is of the form integral of du over u square plus a square. So that will lead us to an arctangent. So that's arctangent x plus 2 plus c. That's 1 over a, that's 1 over 1. Arctangent u, that's x plus 2 over a, that's 1 plus c. That's arctangent x plus 2 plus c. We also have the integral of x dx all over the square root of 3 minus 2x minus x squared. When you look at the numerator, we have an expression x, and we don't like x on the numerator since, you know, this might not lead us to any of these 3 form. Okay. However, so what are we going to do is, you know that the derivative of 3 minus 2x minus x squared is equal to negative 2 minus 2x. What we need to do now is we will be looking for an expression x, okay, such that this derivative negative 2 minus 2x shall appear. Okay, so in order for us to have x, I just multiply this by 1/2. Okay, I think it's negative 1/2 to make it positive x. This is negative 1/2 times negative 2, that is equal to 1. And the negative 1/2 times negative 2x is x. Okay, we now have x, so we need to subtract 1. So this expression, negative 1/2 times the quantity minus 2 minus 2x minus 1 is actually equal to x. So we have, that's it. So we multiply this by negative 1/2, and then we subtract it by 1. Okay. And then after which, you can now use distributive property of division over addition. So we can now have integral of, or this is negative 1/2. You can just throw it out. So that's negative 1/2 integral of negative 2 minus 2x all over the square root of 3 minus 2x minus x squared dx. And then this one, that's negative 1 times the integral of dx all over the square root of 3 minus 2x minus x squared. For the first term, you can now observe that, say, we let v equals 3 minus 2x minus x squared, and dv is negative 2 minus 2x dx, which happens to be on the numerator. So, and this one, we shall facilitate the integral by completing the square. So the first term can now be written of the form negative 1/2 times the integral of, this is your dv over square root of b. And then here, by completing the square, we shall first factor out negative 1. Okay, so that's negative 1 times the quantity, then this x squared will become positive x squared. This negative 2x will become positive 2x. And this positive 3 will become negative 3. And then we shall complete the square. 1/2 of 2 is 1, square is plus 1, and then you subtract 1. So you now have, minus the integral of dx all over the square root of the quantity x squared plus 2x plus 1 minus 3 minus 1. And again, this is a perfect square trinomial whose factor is x plus 1 square. And then you add this 2, that will give you negative 4. So, and this one can now be written as negative 1/2 times 2 v raised to 1/2 when integrated. So this is equal to negative 1/2 times the integral of v raised to negative 1/2 dv. Once you facilitate the integral, that is equal to negative 1/2 v negative 1/2 plus 1, that's 1/2. Then you take the reciprocal of this, so you arrive at negative 1/2 times 2 times v raised to 1/2. And then for this one, so we have minus the integral of dx all over, then this minus 1 will be distributed each term here. Okay, so that will become negative 1 times negative 4, that's positive 4, and negative 1 times x plus 1 squared will become minus x plus 1 squared. And then when you look at it, you can now say that your a squared is equal to 4, and a is equal to 2, and your u squared is x plus 1 square, and therefore your u is x plus 1, and your du is equal to dx. So this is of the form arc sine of u over a. So finally, we have, this is negative 1/2 times 2, that will be negative 1. V raised to 1/2 is square root of v, where v is 3 minus 2x minus x squared. And again, this will lead us to an arc sine of the form arc sine of x plus 1 over 2 plus c. And therefore, the integral of x dx all over the square root of 3 minus 2x minus x squared is equal to the negative of the square root of 3 minus 2x minus x squared minus arc sine of x plus 1 all over 2 plus c. And I think this will be the last. This time we have the integral of the quantity 2y minus 1 dy all over 2y squared minus 6y plus 5. Doing the same process, when you look at it, yeah, the derivative of 2y squared minus 6y plus 5 is in fact equal to 4y minus 6. So we must look for an expression equivalent to 2y minus 1 such that this 4y minus 6 shall appear. So we have 2y minus 1 equals 4y minus 6. To make this 2y, I shall multiply this by 1/2. So I shall now have 1/2 times 4y, that's 2y. Then 1/2 times minus 6 is negative 3. And then we have here minus 1. To make it minus 1, I shall add plus 2. Okay, so that we can have now 2y minus 1. And then we got this. So we shall multiply this 4 minus 6 by 1/2. And then we add 2 at the end. So this 1/2 times the quantity 4y minus 6 plus 2 is still your 2y minus 1. And again, by distributive property of division over addition, so this will become 1/2 times the integral of 4y minus 6 all over 2y squared minus 6y plus 5. And then we now have plus 2 integral of dy all over 2y squared minus 6y plus 5. Okay? And you know that since the derivative of 2y squared minus 6y plus 5 is 4y minus 6, then this integral will give us an ln function. So that is, if we let v, yeah, equals 2y squared minus 6y plus 5, and therefore dv is 4y minus 6 dy, and therefore this will become 1/2 of the integral of dv over v. And for this part, we shall complete the square here. So we first factor out 2. Okay, so you have 2 integral of dy all over 2 times y squared minus that 6y will become 3y. And then 1/2 of 3, 1/2 of negative 3 is negative 3 halves square. So we will be adding 9/4. Okay, plus this is 5. 2 has been factored out. So this will become 5 over 2. We added 9/4. So we must subtract the same number. That's minus 9/4. Okay. And then finally, we shall have, okay, 1/2 ln v. So for 1/2 integral of dv over v, that's 1/2 ln v. And for this one, you can drop this off. Okay. And then that is equal to y minus 3 halves square plus 1/4. So that's this y squared minus 3y plus 9/4 is factored out as y minus 3 halves squared. And then this 5 halves minus 9/4 is equal to 1/4. Oh, yeah. Okay. So since 5 halves can be written as 10 over 4. So 10 minus 9, that's 1. Yeah. And then when you try to look at here, you can now see that your a squared is 1/4 and that a is equal to 1/2 and that u squared is y minus 3 halves square, sorry, and then therefore u is y minus 3 halves, and therefore du is dy. So we shall now have ln of v, where that's 1/2 ln of 2y squared minus 6y plus 5, and then plus 2, what happened here? Hold on. Oh yeah, we can drop this off. Sorry, this one. You can drop this off. Okay, so because that's 2 over 2, yeah, that's arc tangent y minus 3 halves all over 1/2. That's u, that's y minus 3 halves all over 1/2 plus c. And then finally, we can now say that the integral would have been equal to 1/2 ln of 2y squared minus 6y, okay, plus 5 plus arc tangent. Oh yeah, there's 2 here because of this 1/2. 1 over, sorry for that one. Okay, one more. This is 1/4 and a is equal to 1/2. So we have 1 over a, so that's 1 over 1/2. That's why we have 2 here. Yeah, okay. Yeah, I get it. Okay, so that's 1 over 1/2. So that's why we have 2 here. 2 arc tangent u over a. Yeah, I get it right. Thank you. All right. So we have 1/2 ln of 2y squared minus 6y plus 5 plus 2. Okay. Arc tangent of, then this 2 will be multiplied here. So 2 times y, that's 2y. Then 2 times 3 halves is 3. Yeah. So this is the final answer. 1/2 ln of 2y squared minus 6y plus 5 plus 2 arc tangent of 2y minus 3 plus c. All right. And that's it. I think so. Yeah.